All right, here we go. As promised, a few practice problems just so that you guys can get a chance to manipulate these charts or tables. The first practice problem is I've got three number 6 American wire gauge THW copper conductors installed in EMT, ambient temperature of 40 degrees. What is the ampacity of each of the three current carrying conductors? So what are we looking for? First, how many conductors are inside of the pipe? 3. And what's the ambient temperature? 40 degrees C. Our table 310.15b16 is not more than 3 current carrying conductors based on an ambient temperature of 30 degrees C. So right off the bat, I can see I'm going to have to do a temperature correction for this problem. So what is the ampacity? So the first thing I have to do is take a look at my chart 310.15, and we were looking at a THW conductor, which is a 75 degrees C jacket. And what size were those? Those were number 6s. So THW number 6s are good for 65 amps. But we have to take a look at table 310.15b2a because we said we were outside of that 30 degrees Celsius. And for this particular problem, we were at an ambient temperature of 40 degrees C. So I'm going to find 40 degrees Celsius. And where this table matches up with my 75 degrees C, because my conductor jacket was a THW, I have to take that 65 amps and multiply it by 0.88 to find my allowable ampacity. So 65 times 0.88 gives me 57.2 amps. We do not need to use table 310.15b3a because we had no more than 3 current carrying conductors, so we didn't have to make any adjustments here. Here's our final answer of 57.2 amps. And again, 65 times 0.88 gave me 57.2. That's how much current that wire would be able to carry on it without damaging the actual cable itself, the wire itself. Let's look at another practice problem. Okay, a 2-conductor AC cable with 10 American wire gauge 90 degrees C insulated copper conductors is installed in open bar joist areas having an ambient temperature of 105 degrees Fahrenheit. What is the ampacity of the current carrying conductors? So what are these number 10s good for? How much current can they handle with an ambient temperature of 105? So pretty warm. We are less than 3 current carrying conductors, so we're good there. We don't have to make any adjustments. And notice these are 90 degrees C copper. 90 degrees C copper. So let's take a look at 310.15b. 310.15b16. So 90 degrees C, and they were number 10s. So we can see where those two meet up. Good for 40 amps. We said we needed to do an ambient temperature correction. Oops. So for a 105 degrees Fahrenheit, oops. Grabbed the wrong problem. For 105 degrees Fahrenheit, we need to multiply this by 0.87. So now I'm going to take 40 times 0.87, and those number 10s installed inside of that AC cable are only good for 34.8 amps because they were installed in that, warmer environment. 34.8. Again, no adjustment factors for the 3 current carrying conductors. And here's our answer, 40 amps times 0.87 gave us 34.8. All right, number 3. Number 3 says a 3-conductor MC cable with a ground is installed in an area with an ambient temperature of 45 degrees C. The conductors are in the cable are number 2 copper with a 90 degrees C jacket. What is the ampacity of the current carrying conductors? So we said the ambient temperature 45 degrees C, and it looks like I've got 1, 2, 3, 4 conductors. 4 conductors. Well, 3 phase conductors and an equipment grounding conductor. So I have to ask myself, which conductors are we actually counting in this scenario? Are we counting my neutral? Are we counting A phase and B phase? Are we counting my ground? We'll take a look in 310.15, and then this is going to be B3 where it says adjustment factors. So a couple things I wanted to point out. This is going back to what gets counted. So it says where the number of 3 current carrying conductors in a raceway or cable where it exceeds 3, or multi-conductor cables are installed without a spacing of a continuous length of 24 inches and are not installed in raceways, the allowable ampacity of each conductor shall be reduced. Each current carrying conductor of a parallel set of conductors shall be counted as current carrying conductors. And let's continue on. So this was 3A. Take a look at number 5 and number 6 on the next 2 pages, the neutral conductor. So when do we count that neutral conductor here? It says a neutral conductor that carries only the unbalanced current from the other conductors of the same circuit shall not be required to be counted when applying provisions of 310.15b3a. So we don't need to count if it's just carrying the unbalanced current. Shall not be counted, so not counting it. Which in this example, we're actually not sure, what that guy's doing. So B tells us if I've got a 3-wire circuit that uses 2 of the 3 phases of a 4-wire 3-phase circuit and a neutral, you need to count it. And C, when we've got non-linear loads that can create harmonics. Typically, you see this with a lot of the solid state switching devices like VFDs and soft starts. That's going to create harmonic currents, and that's actually going to go back on our neutral. And we're finding out as we begin to install more of these nonlinear loads that our neutrals actually get undersized. It's got more current flow on it now than it ever did. So nonlinear loads we do count. Look at number 6. 6 is grounding or bonding conductor. It says a grounding or bonding conductor shall not be counted when applying the provisions. So in this scenario, we do not have to count it. So going back to my original statement, I was wrong when we counted for 4. we can eliminate that. And I guess I'm making an assumption when I say that, maybe this is they're using this as for a three-phase piece of equipment, or I'm not sure if they're using this just for something where it's fed two phases with a neutral. So I think they're kind of vague in this example, but regardless, we can eliminate that equipment grounding conductor, and we know that we've got 3 or less. So we do not need to make any adjustments. Something else I wanted to point out while we're talking about this is while we're in 3A, if you take a look at number 2, it says adjustment factors shall not apply to conductors in a raceway having a length not exceeding 24 inches. So if it's a 24-inch or less nipple, we don't need to derate for those. I guess their assumption would be, that can dissipate the heat. Just because it's such a short run, it doesn't really matter. But they're saying as long as it's 24 inches or less. So let's go back to our practice problem. Really, the only thing I'm derating for is the ambient temperature. And these are number 2s. So number 2, copper, is back on table 310.15b. Number 2, copper conductor is good for 130 amps. I take that 130 and I multiply it by 0.87, which I get out of the ambient temperature correction table. Again, that was a 90°C conductor and installed in 45°C. So that's where those two columns meet up, is 0.87, giving me an allowable ampacity of 113.1 amps. I like this problem because it gave me a chance to talk about counting that equipment grounding conductor and possibly counting, or maybe not counting, our neutral conductor based on what it's used for, nonlinear loads, or is it just carrying the unbalanced current. Also gave me a chance to talk about adjustment factor for nipples under 24 inches. All right, practice problem 4. Now, this is an example of where I've got more than 3 current carrying conductors in a pipe. This is rigid conduit. So it says 2 3-phase motors are fed with 6 4 American wire gauge THHN copper conductors in the same rigid metal conduit, type RMC, in an ambient temperature of 30°C. What is the ampacity of each current carrying conductor? So fortunate for us, now we're good with the 30°C. That meets table 310.15b, 310.15b16. So we do not need to make any corrections for temperature, but you notice there are 6, so we are going to have to make adjustment for more than 3 current carrying conductors in a pipe. So the first thing I'm going to do is look at number 4s and what type of jacket is a THHN. So a THHN is a 90° jacket. THHN 90°, and number 4s are good for 95 amps. 4s 95. The next thing I need to do is need to go to this table here, 310.15b3, and I got to figure out how many conductors are in my pipe. We said 6, so now I'm going to take that number and multiply it by 80%. pull up my calculator here. So we take 95 times 0.8, which gives us 76 amps. 76 amps. Let's see if we're right. All right. 95 times 0.8, 76. All right, and we'll do one more together. This time we're going to have to use both of the tables. 9, 10 American wire gauge THW and copper current carrying conductors are installed in a 1-inch conduit. Again, it's another rigid conduit in an area with a temperature of 45 degrees C. What is the ampacity of each conductor? So first thing I'm going to do is look and see what is a THWN2 conductor. That is a 75 degrees C wire. And what are number 10s good for? And where those two columns meet up, it tells me 35 amps. THWN2, or I'm sorry, THWN, and number 10s, 35. All right, the next part is I've got to manipulate the second table. Ambient temperature of 45 degrees C, degrees Celsius, 45. And here is my column for my 75 degrees C jacket. So now I need to take and multiply that by 0.82. And then we said we had one more thing that we had to do, is since we had more than 3 current carrying conductors in our rigid conduit, we had 9 of them. And then I'm going to take 9 conductors and multiply it by 70%. So take that times 0.7, which gives me 20.09 amps. So you can see how 9 number 10s, if they were not bundled together or in this ambient temperature, they were good for 35 amps. And now all the way down to 20 because it's in this this scenario here. So here's the answer for that. First we found 10s for 75 degrees C, good for 35 amps. The next step, we multiplied it from the number that we received from the correction chart, and then the adjustment chart for more than 9 current carrying conductor, or more than 3 current carrying conductors. So times 0.7, giving me 20.9 amps. We're going to start off with this next class. We're going to do a few more practice problems together, and hopefully that will spark your memory. Make sure you get in and do the homework. All right.